So let us take parallel RC circuit. Parallel RC circuit. And for which, as like in the RL, so let me take resistance R and a capacitance C, and let me say these are connected in parallel as like this, and if this entire thing is connected across a voltage source and whose nature let me say as V of t, which is generating a current of I of t. Now this I of t going to be split into two parts, which is I R of t and current through the capacitor as IC of t. And if we think of this in phasor domain, so let me take this same diagram, and now let us put everything into phasor form. The voltage is V bar and the current is I bar and this current is IR. These are capital letters, observe that, IR bar, and this is IC bar. So resistive impedance is as like resistance, but capacitance going to change as minus J XC, which is also can be written as XC at an angle of minus 90 degrees. J is equivalent to 90 minus J is equivalent to minus 90 degrees. Clear? Now, as because this is again parallel circuit, so what we do is that we take, so whichever is common for these two elements, which parameter is common? Voltage is common. Voltage is same for R and C, which is V of t. So let us consider V of t as Vm cos omega t. Now immediately let us move to the frequency domain as V bar is equal to, let me write directly, V at an angle 0. What is V is RMS value of the voltage V of t, which is equal to Vm by root 2. Now once we know V, now it is easy to find all the things, that is IR and IC. Once we get IR and IC, add up those two currents, you will get the I. So that same procedure what we seen in RL circuit. So let me do that procedure. IR is equal to V bar divided by R. So V bar is V at an angle 0 divided by R, which is equal to V by R at an angle 0. Similarly, let us take IC. So IC is equal to V bar divided by ZC. So ZC is equal to, so XC at an angle of minus 90 degrees. This is what ZC. ZC is equal to minus JXC, which is equal to, this is XC at an angle of minus 90 degrees. So if we simplify this, we get this as V by XC at an angle of 90 degrees. And we already seen some of the basics on this, that reciprocal of the resistance is the conductance. So I can write V into G at an angle of 90, where G is equal to 1 by R, which is conductance. And here, so I can write, so V into BC capacitive susceptance, where BC is the capacitive susceptance, which is equal to reciprocal of capacitive reactance. So now by using KCL, we can find the current, total current I bar is equal to IR bar plus IC bar, and if we simplify these things, we get VG at an angle 0 plus VBC at an angle 90 degrees. This can be further written as V can be taken common, and these can be expressed into rectangle form as G plus J0 plus 0 plus JBC. So V I had taken common, and I express these things in rectangle form. So this G plus JBC we call as some admittance Y, where Y is equal to G plus JBC, and which can be expressed as mod Y at an angle theta. Now by this time you should be in a position to say what is mod Y? Square root of G square plus BC square. What is the theta? Tan inverse of imaginary part divided by real part. So now this can be written as further V into mod Y at an angle theta. This is what the total current. Now the simple thing that, so we already know all these currents and voltage. Now let us put the phasor diagram again. So as like this, let us take the 0 corresponding reference, which is 0 degree. Now voltage is having a length of V, and this is what V, and whose alignment is along the 0 degree. Next is resistive current, which is having magnitude of V into G, which is V by R actually. See here, V by R, definitely lesser than V. So we can put that current as here. So in the same line, as voltage but lesser length. This is V into G magnitude. What is the angle? This angle is 0, as because it is lying on the 0 degree line. Next is capacitive current. See, where is the capacitive current? 90 degrees plus 90. So positive angles are measured in which direction? Anti-clockwise direction angles are referred as positive angles. So now in this direction I have to move by 90 degrees to get the current. Which current? IC mod. How much is IC? V into BC magnitude. So now in order to get, or let me keep as this. So just draw a parallel line to this. On the tip of the current. Which current? IR. So this is what IC magnitude, and this is what IR magnitude. Now let me remove this portion. IR magnitude is V into G, and IC magnitude is V into BC. Now IR plus IC is what? The I total current. This is what the I. How much is the I magnitude? V into Y, mod Y. See, I magnitude is V into Y. So now how much is the angle made by this current is theta. So positive, so it is in counterclockwise direction. This is what the, current triangle, you can call this as a current triangle, which is phasor diagram of the parallel RC circuit. So from this you can observe that the admittance angle here is theta, which is equal to tan inverse of BC by G, which is called as power factor angle, PF angle. And if you want the power factor, so you can say cos of this angle. So this cos theta can also be expressed from this triangle as adjacent side divided by hypotenuse. What is adjacent side is the current magnitude, which is resistive current, divided by hypotenuse is total current mod I bar. And these things also can be expressed. IR can be written as V into G, and I can be written as V into Y mod, so which can be expressed as G by Y. You can also express sin theta, tan theta, etc. all those things, no issue. So this is what the RC circuit. Now quickly let us see RLC circuit also, then we take up one problem. So parallel RLC circuit, parallel RLC circuit. So now again let me take quickly. So resistor and inductor and a capacitor as like this, and initially I will take everything in time domain as like in the previous case. So here is a certain voltage. So let us say voltage is V of t, which generates a current of I of t. Now the corresponding currents will become resistive current. It is split into three currents: IR of t and IL of t and IC of t, capacitive current, IC of t. So this is what the time domain equivalent. Now if we take up this into frequency domain, just everything will become bar as like this. So in frequency domain this become V bar, this become I bar, this become I R, I suffix R bar, capital letters, observe these things. This become IL bar, this become IC bar, and these things will become ZC, which is equal to minus JXC, which is equal to, so J or let me write this as XC at an angle minus 90. Whichever form we require, we will use that. Here it is equal to ZL, which is equal to JXL, which can be written as XL at an angle of 90. So now, as because just see that what is common for this parallel circuit is voltage. So let the voltage as Vm cos omega t, and immediately express this in phasor form. V bar is equal to V at an angle 0, where V is the RMS value of the magnitude, which is equal to Vm by root 2. So now you can write all the things as like what we seen previously. So I can write quickly IR is equal to V by R, which is equal to V by R at an angle 0. These are already repeated things, so I am writing firstly V into G at an angle 0. IL can be written as V by ZL, which can be written as V at an angle 0 divided by, so XL at an angle 90 degree, which is V by XL at an angle minus 90 degree, which can also be written as V into BL at an angle minus 90 degree. And IC, so V by ZC, so V is V at an angle 0 divided by XC at an angle minus 90 degree. So this is magnitude is V by XC, angle is plus 90. So 1 by XC can be written as BC, capacitive susceptance at an angle of 90 degrees. Now again same principle by using KCL. So what will be the current? I. So I bar is equal to IR bar plus IL bar plus IC bar. Now let us substitute all these end results here. VG at an angle 0 plus VBL at an angle minus 90 and plus VBC at an angle plus 90. And this can be written further that VG minus J VBL plus J V B C. And we can take the real part and imaginary part separately, and by taking voltage common, V into G plus J into BC minus BL. BC minus BL. So this entire thing can be treated as some admittance which is equal to Y. So here let me write beside this. So Y is equal to, so G plus J, so BC minus BL, and this can be written as mod Y at an angle of theta. So what is mod Y here? Is square root of G square plus imaginary part square, BC minus BL whole square. How much is the angle? Tan inverse of, so BC minus BL divided by G. So now I can write Y as mod Y at an angle theta. This let me write V into Y, which is equal to V into mod Y at an angle theta. This is what the total current. Now, so let us go with the phasor diagram. So quickly. So for which I will take usually these things 0 degree line, then voltage is what we know, whose magnitude is V. So that is what the length of the voltage, and it is lying on the 0 degree line, which represents V at an angle 0. Next immediate step is current through the resistor. Current through the resistor is, so I R mod, which is equal to V into G, and whose angle is 0. We already seen here. See, whose angle is 0. 0. And next is IL, whose angle is minus 90. IC angle is plus 90. So minus 90 means downward. So let me say IL is downward. This is what the IL magnitude. So let me say IC is upward, whose angle is positive, IC. So now, as like in the previous case, the condition that if IC magnitude is more than IL magnitude, then how does it look like? Is that the phasor diagram going to be shifted as like this. So let me take here this entire thing. Now IC is more means, let me draw this IL to be little small as like this. So let me use same color. This is what IL magnitude. Now what I need to do is that just let me take the copy of these two at the tip of resistor current, and let me subtract this IL value from the IC as like this. So from the IC I am subtracting IL. So let me remove all these things. Just we already know what are all these. Green color means IL, this light blue color means IC. So the left out thing is what? The left out thing is this much, which is what? IC mod minus IL mod. Now IR plus IC plus IL. IC plus IL means IC minus IL. Why? Because it is phase opposition. So that net is what? The total current, which is what? The I bar magnitude, whose angle is theta, like this. Just quickly let me proceed with some other condition. If IC is lesser than IL, how we get? What kind of diagram we will get? So sorry, let me take this diagram again. So this diagram again, and just quickly let me produce that corresponding diagram. So now these things will vanish. So now what is more? IL is more. So let me draw this IL to be more length than IC. This is what the IL magnitude, and IC magnitude let me draw little smaller as like this. Clear? So just based on these equations I am getting all the things. So now if I'll add up these two currents first, how much I'll get is, let me put that resultant over here, and if I'll take out this amount of the capacitive current, the left out current is what this is what the left out current. Once I'll add up the inductive current and capacitive current. Pink color current is what the left out current, which is IL minus IC. Now IL minus IC plus IR, this red color one is what the IR, what it gives as the total current, which is I bar, and whose angle is theta. So in this way you can produce the phasor diagram for the RLC circuit for these two conditions, that if inductive current is more, the second diagram; if capacitive current is more, this first diagram. Okay.